In this video, we are going to be looking at questions from tutorial sheet 2, which is on functions. Okay, so this is Unilas campus. All right, so this tutorial sheet has a lot of questions. We are going to solve them one by one. So starting from question 1 all the way up to the last question here, which is question 6. Okay, so we are going to solve all these one by one, and I'm going to explain each one. All right, so if you'd like to access the full video to this tutorial sheet, you can register using our website. Find the link in the description. There's also a video guide. So make sure you watch the video guide and then you go to the website and then you can register and then you'll be able to find the full video for this tutorial sheet. So we start from question 1A. All right, so question 1A, they're saying, okay, let the function f of x be 1 over x minus 2, and the function g of x be the root of x plus 1. So the first question here, they're saying state the domains of f of x and g of x. Okay, so to state the domain of a function, we first have to identify what kind of function it is. So this function f of x, okay, has been given in form of something that we can see as a fraction because I have a numerator and the denominator. Okay, so to find the domain, okay, to find the domain of a rational function, okay, because this is in form of a fraction, so we call it as a rational function. So to find the domain of a rational function, you just have to make sure that the denominator is never 0. Because if the denominator becomes 0, then the function becomes what? Invalid. Okay, so we're just going to get the denominator and then say this x minus 2 should never be equals to what? 0. Okay, so it means x should never be equals to what? Positive 2. So it means our domain will be the set of all real numbers apart from what? These two. So we're going to say the domain is going to be equals to set of all the x's such that x is a real number, okay? But this x is never equal to what? To 2. So this one here will be our domain for the function f of x. All right, so what about the domain of the function g of x? So the function g of x, we can see that it has a square root, okay? So whenever you see a function with a square root, that function is called a radical function, okay? So to find the domain of a radical function, you need to make sure that, okay, what is under the root is never a negative number, okay? Because you can't find the root of -5 if you're considering the set of real numbers, unless you go to the complex numbers. But here we're considering the set of real numbers. So there's no square root for -100, okay, if you're considering real numbers. So you have to make sure that what you have under the root here is always 0 or positive, okay? So meaning it's non-negative. So we have to make sure that x plus 1 is always greater than or equals to what? 0. All right, and then from here we can find the domain. So we are going to say x should always be greater than or equals to what? -1. So it means the domain of the function g of x, okay, will just be a set of all the x's such that x is a member of these real numbers, okay, where x is greater than or equals to what? -1, like this. So this one in yellow is the domain of g of x, and then this one in red is the domain of what? F of x. All right, so we are done with the first question. Let's look at the second question. So the second question, they're saying what now? So on the second question, they're saying determine the domain of the composite functions f of g of x and then g of f of x. All right, so here we have a composite function. So it means for us to find the domain, we're going to consider the domain of the input function. Okay, so the input function is the function that you are putting into the other function. So if I write f of g of x, okay, it means this g here is the input function because I'm getting this g of x and inputting it into the function what? F. Okay, so for me to find the domain of a composite function, I'll first of all find the domain of this input function, okay, and then combine that domain, combine that domain of the input function with the domain of this whole composite function. Okay, so this f of g of x, we said it means that we get the function of g and input it into f. Okay, so first of all, you write the function of f here. So the function of f is just 1 divided by x minus 2. Okay, and then this will be equals to, so wherever there's x now, we're going to put the function of what? G of x. So the function of g of x is the root of x plus 1. So this will be 1 divided by, where there's x, we put the function of g of x, which is the root of x plus 1, and then we still have this minus 2 there. Okay, so this guy here has just replaced this x. Okay, and then from there, what are we going to have? What are we going to have from there? We're going to say this here is the same as 1 divided by the root of x plus 1, okay, and then minus 2. So what we found here is our composite function, what? F of g of x, okay? So we need to find the domain of this composite function and then combine it with the domain of this input function here, which is g. Okay, so the domain of g is just this one here in yellow. So let's find the domain of this guy. So this guy here now has become a rational function in terms of a fraction. So we said the rational function, for us to find the domain, we just have to make sure that the denominator there is never 0. So what are we going to say? We're going to say the root of x plus 1 minus 2 should not be equal to what? To 0. Okay? And then from here we solve for x. So this will be the root of x plus 1 should not be equals to. We take this to the other side, it will become 2. Okay, and then from there we are going to say let's square both sides. So if I square this side and also I square this side, what am I going to have? Okay, here I'm going to have x plus 1 is not equals to. Then here when I square this 2, I'm going to get 4. Right, let's erase some of these things here. So it means the domain there will just be equals to what? Okay, the domain will be all real numbers except x 4, and then we take this 1 to the other side to be minus 1. So it will be x should not be equals to what? 3. So this is the domain that we get from the composite function of f of g of x, okay? And then we said we also have to consider the domain of the input function, which is g, okay? So we have to combine this domain here for the g with this domain for the what? For the composite function, okay? So we are going to say the domain, okay? The domain for the composite function f of g of x will just be a set of all the x's such that x is a real number, okay? And x is greater than or equals to minus 1, okay? And x is not equal to what? To 3. So this one here that I've written there will be our what? Our domain. Okay, if you want, you can put this domain in interval notation. So in interval notation, it's going to look something like this. So this x is greater than or equal to minus 1. It means it's starting at minus 1, and then it's going all the way until the 3. But we do not include the 3, so we're going to put a curved bracket like this. Then we're going to say union. Again, we start at a number just slightly above 3, okay? And then we go all the way to what? To positive infinity. Okay, so you can represent your domain for the composite function as this one, or you can represent it as this one. Okay, so what we are remaining with now is to find the domain of this composite function here, which is g of f of x. All right, so I'll erase this part. Okay, so for us to find the domain of g of f of x, we first of all have to consider the domain of this input function, which is f. Okay, so the domain of this input function f is what we have here. So what we have to do now is just to find the domain of this composite function. Okay, so let's find the composite function. So the composite function will be g of f of x is equals to, first of all, let's just write the function for g, which is the root of x plus 1. Okay, and then now let's substitute wherever there's x, we put the function of f of x. Okay, so this is x here. So on that x, I'm going to put the function of f of x. So it will be the root of, where there's x, I put 1 divided by x minus 2 and then plus 1. Okay, so this is what I have. And then from there, what am I going to do? Okay, from there, I can just say that for me to find the domain of this composite function, I just have to make sure that whatever I have under the root here, maybe I should use a different card. Whatever I have under the root here, okay, should always be what? Non-negative. Okay, so non-negative means what? Means that 1 minus x minus 2, I mean 1 divided by 1 divided by x minus 2 plus 1 should always be greater than or equal to what? 0. So the domain that we are going to get from here, we're going to combine it with the domain for the what? The input function. All right, so here we are going to have an inequality. So this inequality, we are going to solve it using a table. So this one here, let's combine it. So 1 over x minus 2 plus 1 divided by 1 is greater than or equal to what? To 0. So here we're going to say this is x minus 2, okay, greater than or equals to 0. Then this x minus 2 into x minus 2 is 1. 1 multiplied by 1 is just going to give me 1. Okay, and then from there, it will be 1 into this. It will give you this multiplied by 1. It will give you plus x, and then minus what? Minus 2. So what we get from there will just be, let's erase this part. What we get from there will just be, okay, just be x minus 1 on top, and then x minus 2 above, and then greater than or equals to 0. So whenever you're dealing with inequalities, okay, never cross multiply. Okay, we just have to find the regions where this equation will be true. Okay, so we have to find the regions where this equation here will be greater than or equal to what? To 0. So how are we going to do that? Okay, we're going to find what we call as critical points. Okay, so these critical points, we just get them by equating this x minus 1 to 0 to find the value of x, even this x minus 2 to 0 to find the value of x. So if I equate x minus 1 to 0, I'm going to get x is equals to 1. And then when I equate x minus 2 to 0, I'm going to get x is equals to what? 2. So this one here, or these ones here, are the critical values. Okay, then we are going to use these critical values to test. Okay, so we're going to say, let's divide this table into about 4 regions. Okay, so we're going to say, let my 1 be there, okay, and then my 2 be there. And then here I'm going to put these equations. So x minus 1, and then x minus 2, and then down there I'm going to say overall. Okay, overall means x minus 1 divided by x minus 2. So if you want, you can just put the same function there. All right, and then we're going to test values. So we're going to test a value that will be less than 1. So a value that is less than 1, we can test 0 there. So in this region, we're going to be testing 0. And then here between 1 and 2, we're going to test 1.5. And then after 2, we're going to test 3. Okay, so those are the things that we are going to test there. All right, so let's write the signs, okay, of these equations here when we test them with these values that I've circled in blue. So if I put 0 on this x, I'm going to get minus 1. So it means here I'll get a minus, okay? If I put 0 into this x minus 2, I'm going to get a minus again as well. And then if I put 1.5 into here, it will be 1.5 minus 1, I'll get a positive answer. If I put 1.5 here, it will be 1.5 minus 2, I'll get a minus answer. If I put 3 there, I'm going to get positive. If I put 3 there, I'm going to get positive. So the overall now, you just have to multiply the signs that you have on top. So negative multiplied by negative, I get positive. Positive multiplied by negative, I get minus. Positive multiplied by positive, I get what? Positive, like that. Okay, so now you go back to your equations here, to your equation here. So your equation says whatever expression that you have here should be greater than or equals to what? To 0. So it means it should be for positive or 0. So it means the region that we are interested in will just be these regions here, where this overall equation or this overall function is what? Positive. Okay, so we're going to get this part from minus infinity, okay, all the way to positive 1. And then we're also going to get this part from positive 2 all the way to what? Positive infinity. Okay, so our domain from this sine graph that I drew here will just be minus infinity, okay, all the way to 1, So the 1 is included here because in the question we had the greater than or equals to, okay? So to be included, and then I'm going to say union. So even this 2 here will be included because we have that sign, so it will be 2, and then all the way to what? Positive infinity. So this is the domain that you get for your composite function, okay? So remember we said the final domain should be a combination of the domain of the composite function with the domain of the what? The input function. All right. So the input function here was what? Okay. So the input function at the domain of this, where we said x should never be equals to 2. Okay. But here we see that this guy here includes the 2. So we have now to remove the 2 from the overall domain. So we're going to say domain of the overall composite function, which is g of f of x, will just be equals to a set of all the x's such that x is a real number, okay? And then now I just write, I think let me write the domain in just the interval notation. So I'm going to say the domain is equals to, okay, minus infinity all the way to 1, and then union. Okay, so remember in the domain for the composite, the 2 is included, but here in the domain of the input function, the 2 is not included. So it means in the overall domain, we should not have a 2, because if we have a 2, then the input function will be invalid, and ultimately the output function, the composite function will also be invalid. So we remove the 2 from the domain. So what are we going to do? We're going to change this bracket, the type of bracket that we have there, because this square one here means that we're including these 2. So we're going to say a curved one, and then 2, and then all the way to what? Positive infinity, like that. So this one here is the domain of the composite function g of f of x. Right, so we are done with our question 1. So as I said, if you'd like to access the videos to all these questions, okay, I solved them already. They are there on our website. Just check in the description below, okay, and then you'll be able to register, and then you'll be able to access the video to all these questions here. I already solved them. They're there on the what? On the website. All right, so thank you so much for watching. This has been Tutor Post Solutions. Until next time.